Welcome to a segment in dynamic programming DP. So to show you how to use DP, I'm going to solve 4 palindromic questions ranging from easy to difficult. So the first one you do not need to use DP for, but the reason why I want to use DP is so I can show you a pattern, and in this pattern you can answer almost any palindrome question you are giving on an interview. I promise this would always work, no matter how difficult the problem is. So I'm going to show you a pattern with something really easy, using DP, and then you would see the setup, and then you can use that same setup to solve all the types of problems. So in this video we'll tackle the first problem, and then there are links to other videos that tackle the other questions. Thank you. Alright, so let's begin. So giving a string, determine if the string is a palindrome. So what is a palindrome? Palindrome is a string that reads the same going forward and backwards. So BABAB is a palindrome. It reads the same going forward and backward. This is not a palindrome. This is a palindrome. This is not. AC is not, because CA and AC are not equal, and A is. So there is another way to solve this problem without using dynamic programming, guys. You can just take the string, reverse it, and see if the two strings are equal just by reversing it. So you do not have to use DP to solve this problem, but I'm using DP because I want to show you a pattern that you can use for other problems. So let's begin our solution. So the first thing in DP is, the goal is we want to find if something is a palindrome. So let me just S is the string that we're taking in. So I'm going to create the length for S just so it makes my life easy. The next thing is, since we're looking for to find out if something is a palindrome, so let's just create a palindrome flag, whatever, and let's call that false. And then let's create our palindrome. I said our palindrome. Let's create our array. So array of size n, and then we are going to fill that with anything, 0. And then so if S is a string 1, like if S is A, for instance, this is going to be an array of 1 element. So then for each element, I'm going to do a map, return an array of that. So now I'm creating like a matrix, an array of that of similar length size, and fill that with false. So this is, you always do this. This is the first step you always have to do. Again, this is a pattern that you must follow. Alright, so that's that. So now let's start with cases. When you're using DP, there are multiple cases. We have the base case, the most simplest case, and then it goes on for that. So in this case, we're going to start with the easiest case, A. So so let's say case when the string we have A, this is always a palindrome, so we need to figure that out. So we can say for let I equals 0, I is less than n, because this is I itself here. So I will be 0, n here is 1, 0 is less than 1. That makes sense. Perfect. I plus plus. And then we'll say dp of I to I equals true. So we're just filling out our array. That's all we're doing here. We're setting the array. We're making it diagonal. So if this was AA, the diagonal would be true. But in this case, this is A, so the array would be true. I'm going to show you what this will look like. And then we'll say palindrome equals true in this case. So this is an easy set. We can return this. We can return palindrome. But I also want to print out DP, so you can see what DP looks like. Okay, so let's do that. This is for case A with just one character. So let's print that out and see. Make this a little bigger. Okay, perfect. Node tutorial. Beautiful. Wait, that am I printing out the right thing? Yes, I am. Oh, that's because I'm calling all of them. I'm sorry, guys. So let me just comment this out. I'm just calling the first one A. All right, so let's do that again. There we go. So true. So it creates first it creates the outside array, and then for each element inside the outside array, it creates another array for each element, and it fills it with true. No, it doesn't fill it with true, it fills it with false. But then once we go through this iteration over here, it fills it with true, and it returns true, obviously, because any single character is a palindrome. So now we're gonna do a case of two characters, AB or AA. So we need to determine if this is a palindrome. AB is not a palindrome, but AA is a palindrome. So we'll say for let R is the row, R is less than N, R plus plus. Let's see what we're doing here. And then for let C equals R plus 1, C is greater than R, and C minus minus. So let's understand what's going on here. R is 0, so R is going to start from A. So string of R. So what I'm saying is this. So S is our string. So S of R, S of 0 is A. We know that. So we're going to start with that. And then we're going to move up to the next one. R is 0. So if N, so in this case, N is 2, right? So if N is 2, we want to check the first two. So 0 and then 1. But we do not want C to go to pass 1. So in that case, this should be N minus 1. Because if N is 2, 2 minus 1 is 1. So R would be just 0 alone. So R is 0 and then C will stay here. That's it. So then we'll just check both. So let's see how this works. And then we'll say if S of R equals S of C, if this is true, then palindrome equals true. And then we can say dp of R and dp of C equals true. So we're just filling out the array equals true. That's what we're doing here. All right, so this is good. So let's try our next one. Let's uncomment this out. And then we can comment this one out. There we go. And we'll try AA next. So AC should give you false. True, false, false, true. Let's see what happened. Why is it giving us that? AC should give you false. It's not a palindrome. Oh, that's because I forgot the else case. Else palindrome equals false. So it's just setting as true after the first one, which is not the case. There we go. Makes sense now. False. All right, so it's taking let me just explain this really quick. So when the first pointer points to A, R is 0. So the pointer is at A right now. Let me make this bigger. So the pointer is at A right now. And then for C is at R plus 1, 0 plus 1. So C is at B. So now it says if S of R equals S of C, does A equal B? No. So palindrome equals false. It's really simple. Now let's move on to the next one. R starts here, and then S of C starts in the second A. If S of R equals S of C, does A equal A? Yes. It's a palindrome. So palindrome equals true. Sets the array to true. That's it. It's really simple. That's all we're doing here. All right, so let's do the final case. Now this case it's really our DP solution. DP solution. Here we're gonna check for ABA. We're gonna check for things like ABB, and or greater. It doesn't matter, any size. So we would try the other ones. So while we're doing let me just show you that. So let's try AA. AA should return true. True. Perfect. True, true, false, true. Because AA is true, AA is the same, so it sets these two values to true. AB are not the same, so hence you have true, false. Okay, awesome. All right, so let's let me close this. Now let's solve for the bigger case. So here we're gonna start with for let C equals 2. I'm gonna explain. C is less than N. C plus plus. For let R, which is the row. C stands for column, R stands for row. 0, R plus C less than N, and then R plus plus. All right, so before I do anything here, let's say W equals R plus C. Before I move on, let me just explain what's going on. So here, since we've done case for string 1, for length 1, we've done case for length 2. Next is length 3 or higher. Because of that, I start my column at 2, 0, 1, 2. So the third character. So that's where my C stands for. So my C starts with A here. So we can even make this one bigger. Let's say B A B A B. So my C starts here. In this case, my C will start from the middle B. Over here. Let's make it bigger. So my C will start from the middle B with this one over here. Perfect. All right. So now what's going on here is that R equals 0. So R is going to start from A, and C is going to start from A. And then my next obvious question is, does if S of R equal S of W? Why W? Because W is R plus C. R is 0, C is 2, so 0 plus 2. So we can skip whatever is in between them. So W is the length of that string, actually, is the length of the substring. That's the tricky part. W actually signifies the length of the substring. So W here is 0, 1, 2. So does S of R equals S of W? In this case, it does equal. So anything in between has to be a palindrome. It doesn't matter if this is R, T, Y, it doesn't matter. But the fact that the first and the last are equal, that whole entire substring is a palindrome. Now, here's a pattern. So let's say it's greater than 3. So we'll start at B here, and then we'll be at B over here. So we'll compare. Is this a palindrome? Yes. The first 3 is a palindrome. Perfect. Then what happens now is we're going to move to the next one. R moves to A, and then C moves to this A. Then it checks. Is this 3 a palindrome? Yes. It moves to the next one, and further and further and further. What happens here is that, so that's a subset. The original case is R starts at B, and then C starts at this B, and then see how C goes higher. So C then moves to the next A, and then moves to the next B. Hence, it will check, is B A palindrome? The answer is yes, it is a palindrome. So let's see an example of it first. There's one last thing we actually have to check. So we know that ABA is a palindrome because of this condition here. S of R equal does S of R equal to S of W? Yes, it does equal, but we need to make sure that the middle is true, because when it goes through these operations, it's going to mark it as true or false. In this case, this B is going to be false. We saw it over here, true, false. Here is true, true, because they're the same thing. So we need to ensure that this is true. So to do that, we'll say if dp of R plus 1, why am I saying plus 1? Because if R is here, R plus 1 is going to point to B, so R plus 1. And then W minus 1. Why W minus 1? Because if W is here, W is at the last one, W minus 1 goes back to B. So hence, checks confirm if this is true. That's what we're doing. So if this is true, let's create our else case. If this is true, then we have a palindrome. That's all it is. Palindrome equals true. And then we say dp of R and dp of W equals true. If this is not true, then we have palindrome equals false. And that's it. This is our dp solution right here. So we can test this out. So let's remove these 3. No, let's leave that. So let's test these 2. Let's comment out the dp. I don't really want to see this part. Okay, let's make it smaller. All right, so the first one obviously is not a palindrome. The second one is a palindrome. So let's test that. Perfect. False. True. And no matter how big it gets, you can do another one. Let's make it another one. Put an A there. Boom. I think this is a palindrome, guys. I think so. Let's see. I think so. Yes, it is. So let's see. True. Perfect. So that works. Thanks, guys. Leave comments, and if you're not subscribed, please subscribe.